Assalamualaikum warahmatullahi wabarakatuh. Today we are going to present about Road Safety Audit RSA. My name is Fatina Roslinda binti Ali. My matrix number is 2022961721. I am a first presenter. What is Road Safety Audit RSA? A Road Safety Audit RSA is a systematic, formal and independent review process aimed at identifying potentially safety risks in road project or existing roadways. The primary goal is to ensure that the safety of all road users such as driver, pedestrians, cyclists and motorcyclists by detecting and addressing safety concerns at every stage of a road's life cycle. Purpose of Road Safety Audit. The primary purpose of an RSA is to ensure road infrastructure, minimize the likelihood of accident, and reduce the severity of those that do occur. By identifying issues like poor visibility, unsafe road geometry, inadequate signage, or hazardous pedestrian crossing, RSA helps in designing safer and more efficient road networks. Why we need conduct a road safety audit? First, prevent accident and save life. Identify potential safety hazards that may lead to crashes and to reduce the risk of road accidents by addressing issues in design, construction, or operation. Second, improve road user safety. Ensure that road cater to the needs of all users, including driver, pedestrian, cyclists, and motorcyclists. To address specific safety challenges like vulnerable road users such as children, elderly, and disabled. Third, proactive hazard identification to detect issues early in planning or design stage before they become costly or dangerous, and to focus on preventing accidents rather than reacting to them after they occur. Lastly, enhance design and construction standards to ensure road design comply with modern safety standards and best practice, and to identify shortcomings in road geometry, signage, lighting, and other features. That's all from me.
Hi, my name is Nur HK binti Muhammad Zahir. So, for the objective to this project, first to perform a true road safety audit of a particular roundabout located on UiTM Shah Alam. Second, to identify and analyze traffic issue by collecting relevant data and if the parameter. So, the third, to determine specific safety concern at the roundabout and propose particular solution to improve safety and operating efficiency. To conduct this project, we have a 4 stage. First, determine the roundabout. Second, determine suitable experiment and conduct analysis. Third, identify road safety issue at the selected roundabout. Lastly, propose solution to the safety issue. Stage 1, determine the roundabout. For this project, we conduct to select the roundabout near College Seroja. Furthermore, this is the layout of the roundabout. To measure the dimension and diameter roundabout, we use a roller meter, and this is the way how to use roller meter to measure road dimension.
So next is stage 2. Basically, for stage 2, the task is to determine suitable experiment and conduct the analysis. The first study that we have conducted was spot speed study. So these are the apparatus that involved in this study, which are laser gun, stopwatch, measuring wheel, and also spot speed study data form. The data has been collected on 2 different days, which are the first one was on 9 January 2025, which is in the evening from 5:15 p.m. to 6:15 p.m. And the other one was on 10 January 2025, which is in the morning. So, the objective for this study are to measure vehicle speed at various points around the roundabout and to set appropriate speed limit for both new and old roundabout in order to ensure safe driving when vehicles approach and pass them. Next, the procedure for this spot speed study are laser speed gun, stopwatch, pens, speed study data form, and other necessary supplies were prepared before starting to collect the spot speed data at roundabout in front of College Seroja. Vehicles will be chosen randomly to record the speeds. To ensure a direct line of sight with approaching traffic, the laser meter was placed as close to the road as feasible. The speed of vehicles will be tracked and recorded until it reaches 100 samples, or for 1 hour duration. So, basically for the data analysis, we have 3 different directions, which are direction 1, direction 2, and direction 3. But all 3 directions will be taken its data for both evening and morning in 2 different days. By right, we have 3 different data for each lane for both evening and night. So by collecting all the speed data and classifying it into its own classes, we will have 100 samples of data that have different speed interval. And we also can determine the frequency and also the cumulative frequency based on the data. By that, we can produce 3 different graphs, which are frequency histogram, frequency distribution graph, and also cumulative frequency graph. From cumulative frequency graph, we will be able to determine the value for P15, P85, and also P98. So basically, this is a summary for data analysis for direction 1 in the evening. This is the data for direction 2 on the evening. This is the data for direction 3 on the evening. This is the data for direction 1 on the morning. This is the data for direction 2 on the morning. And last one, this is the data for direction 3 on the morning.
Now, I'm going to show you how to use a laser gun. First, let's look for a hidden place when using a laser gun. Second, we need to press the button on to turn on the laser gun. Wait until the laser gun beeps and the laser gun can be used after beeping. Next, point the laser gun at the rear of a passing vehicle. Press the button on at the laser gun body until it beeps and the vehicle speed data will be displayed on the laser gun screen. For example, the speed reading for that car is 37 km per hour.
This is an example if you want to take vehicle speed data from the front of the vehicle. The laser gun must be pointed toward the front of the passing vehicle.
Hello everyone. Now I will show the procedure for conducting a traffic volume study at College Saroja roundabout using a telecounter. The objective of the study is to collect and analyze traffic volume data at the roundabout to determine traffic flow characteristic and peak hour traffic. Before we begin, let's go over the materials needed for the study. First, we need a telecounter, a stopwatch, and a datasheet. Step 1. Before starting the count, I will reset the telecounter to 0. Step 2. Each time a vehicle passes, I will press the button. Step 3. At the end of each 5-minute interval, I will record the count on my datasheet. Procedures. Select a safe point with a clear view of the roundabout and all lanes. Start the stopwatch and conduct the study for a total duration of 60 minutes. As vehicles enter and exit the roundabout, use the telecounter to record the numbers. Collect traffic data in 5-minute interval to ensure accurate analysis. After the 60-minute period, summarize the collected data by adding up the vehicles counts. Finally, analyze the collected data to calculate the total traffic volume and identify peak hours. For data analysis, we will record a total of 337 vehicles. To analyze the traffic impact, we use specific roundabout PCU values for each vehicle type. As you can see, from the PCU table, we can conclude that the total PCU per hour is 277.69. From the graph, the breakdown of vehicle type show that 71% were passenger cars and small vans, 1.19% were lorries, and 27.59% were motorcycles. From the summary table, we can conclude that peak hourly volume is 337, peak hour factor is 0.73, design hourly volume is 461.64 vehicles per hour, average traffic is 28 vehicles for every 5 minutes, and average daily traffic 8,088 vehicles per day.
So for stage 3, basically we will be determining the road signalized issue at roundabout in front of College Saroja. Some of the main things that we will be observed are by checking the road marking, the condition of the roundabout, the signboard that has been placed at this area, the condition of the street light, and the lane for every road at this selected area.
In stage 3 of the road safety audit, we thoroughly analyze the roundabout near College Saroja to identify the key safety challenges affecting driving and other road users. First, we observed that the roundabout does not have driver's yellow bar, which are critical for warning drivers to slow down as they approach. This absence increases the likelihood of speeding and accidents. Secondly, the lane marking on the roundabout are either faded or unclear, leading to confusion about the correct lane to use, especially during peak hour or nighttime driving. Additionally, the pavement and street condition are problematic. Potholes are evidence which pose significant hazard, particularly for motorcyclists who may lose control. Poor drainage around the roundabout, increasing the risk of sliding during wet condition. The some cover are not level with the pavement, creating bump that can disrupt the flow of traffic and pose risk to smaller vehicles. Lastly, we identify multiple issues related to the road furniture. Speed limit signage was entirely absent at all, leading to and from the roundabout, leaving driver unaware of the safe speed to maintain. The existing road signs are either damaged or insufficient, failing to provide proper navigation guidelines. Street lighting was also inadequate, reducing visibility at night and making it unsafe for all road users. This combined factor significantly impact the safety and efficiency of the roundabout. After identifying the issue, we move to stage 4, where we propose practical solution to address the safety concern at the roundabout. To address the absence of driver's yellow bar, we recommend installing them across all approaches to the roundabout. This bar provides a tactile and visual warning to driver, encouraging them to reduce their speed. Similarly, repainting the lane marking with the addition of reflective material, we ensure that lanes are clearly visible, especially at night or in low visibility condition. For the pavement and street condition, potholes should be patched properly to eliminate hazard, particularly for motorcyclists and cyclists. Some cover need to be raised to align with the pavement level, ensuring a smoother driving surface and preventing vehicle from encountering unexpected bumps. To resolve the drainage problem, the drainage system should be improved to prevent water pooling with its major cascading. To tackle the road furniture issue, we propose installing speed limit signs at every junction to inform driver of the appropriate speed for the roundabout. Damaged or missing signs should be repaired or replaced, and additional signs should be added to provide clear navigation guidance. Improving the street lighting by repairing existing light and installing additional one will enhance visible, particularly during nighttime or adverse weather condition. Lastly, installing road hump at key points around the roundabout will further control vehicle speed, ensuring the safety of all road users. This combined solution aims to create a safer, more efficient roundabout that minimizes risk and ensure smoother traffic flow for